Good evening, Classy. I want to welcome you to Term 4 Work Natural Science Grade 8. Today we want to talk about the planet and beyond. In this presentation or in this lecture, we are basically going to look at our home planet and everything in the in the universe, encompassing the solar system, the Milky Way galaxy, the other galaxies, which includes the celestial bodies like planets, stars, and moons. Basically, this topic, this is a broad topic that explores the Earth's position in the cosmos, which we refer to its natural phenomenon like weather and plate movement anyway. So what we need to understand is that in today's presentation, we need to understand and defining the planet Earth and beyond. Uh, what actually constitutes the planet? What are the characteristics of the planet Earth? And also, we want to look at all celestial bodies and structures outside the Earth, that is including the solar system, where we look at the sun and its eight orbiting planets, which of course include the Earth, the moons, and other objects like the Kuiper belt. So now, what I want you to understand is that we want to look at galaxies, the vast collection of stars and gases and dust, which is also part of this today. I mean, which is part of this presentation. So galaxies. I'm sure that you remember that we are looking at the vast collection of stars, the gases, the dusty, and the dark matter, such as also the Milky Way galaxy, which contains billions of stars and also planets, the universe, everything that exists, the ultimate building blocks of what of the universe. So we are basically going to look at these in this presentation. So let's just be patient and follow the presentation as we go. Uh, the solar system the solar system, the sun is a star, and like other stars in the universe, continuously producing large amount of light and heat energy. That is basically what we mean by the sun. We have got major terminologies that we are going to use or that we are going to go through here. These terminologies, you would find out that they need to be understood such that as we go forward, you will be also relating very smartly. So when we look at the core, it's actually we need to know to be the center of an object. When we talk about the core, it is the center of an object. In this lesson, we are actually referring to the core of the sun, the center of the sun, or the core, as to say the sun, the core of the sun, and then fusion, combining, mixing, or joining together. We shall find out that terms such as these are going to be continuously, repeatedly used. What is fusion? Combining, mixing, or joining together. When two things are combining, when things are two or more things are mixing up or joining, we define that as fusion. And then gas planets are the planets that are mainly made of gas, with small centers of rock materials. I say that we are looking at the Earth and beyond. So we have got planets that are mainly made of gas, which are with small centers of rock materials. And then we also have what is called nuclear fusion, when nuclei join together to form a new nucleus and energy is released in that regard. In that film, we say it is called nuclear fusion. And then orbit, the oval shaped pathway that it takes to travel around the sun. It's a pathway which is oval, which is eclipsed, which we are saying it's egg shaped. That actually which actually is the Earth pathway that it takes to travel around the sun. And then terrestrial planets, this refers to the planets with rock surfaces. For example, we talk about the Earth, Mars, Venus, and also Mercury. We are looking at the what terrestrial. They refer to land. We refer terrestrial as to what as to it also relates to what to land. So uh, going forward, we are going to see that these terms are going to continuously repeat as we go. So the sun is a medium-sized star, which at the center of the solar system, it looks bigger and brighter than other stars. The sun, it is basically a medium-sized star, which at the center of the solar system, it looks bigger and brighter than the other stars people can see because it is closer to the earth. So the distance of the sun to the earth is also closer and other stars. So even though the sun is an ordinary star, it is the most important star that gives life on earth. I'm sure, remember, when we talk about this, we shall see as we go forward with science, you shall see that we need to understand that life on earth also revolves on light. It revolves on heat. So heat energy gives the vegetation that we have. The light energy that we have supports the biotic life that we can talk about in any form or in any case. So the sun is a star which is a giant ball of ionized gases. It's a giant ball of ionized gases called the plasma. And then the sun is mostly hydrogen with 74% hydrogen and also 24% helium. So with all other elements of the periodic table making up only a total of 2% of the sun's matter. That is when we refer to the sun here. So the sun has layers like an onion. When we look on the sun, it has got layers like an onion, and the layer that our eyes can see is called the photosphere. Photo means light. The photosphere is the layer that our eyes can see. The photosphere is the layer that our eyes can see, and it is the layer of the sun that gives off visible light. The layer that gives off visible light, we are saying that you need to understand that it's called photosphere because the sun is actually it's actually like an onion, and then the star is a pod of hot glowing gases in the space that produce its own energy. It has got a body of hot glowing gases in the space that produce its own energy. And the energy from the sun comes from the powerful nuclear reactions where hydrogen gas is converted into helium. Hydrogen gas is converted into helium. We have got an explanation that identifies this conversion of hydrogen into helium, which we are going to look at as we go forward with this presentation. So basically, we are saying the sun, it actually gives the earth the light and heat energy that it actually depends on. And again, we need to understand that it is actually the sun that is it is layered. It is a layered structure which has got the photosphere that actually provides the earth with the visible light that we are talking about or that we depend on. That is one thing that we need to look at. And then we have got the structure of the sun, which I was saying we need to be able to know and look at. We should be able to see it and be able to relate to it. We have got the corona, which is the outermost layer observed during a solar eclipse. When we talk about solar eclipse, we have got the what? The corona, which actually is the outermost layer that we see during solar eclipse, and then reaching deep into the solar system. It is the called what? It is called the corona. And then we have got the chromosphere. Chromosphere Chromosphere is actually a relatively thin layer which builds on the photosphere. It builds on the photosphere, which means it builds on the layer that we see that provides light. And the eruptions happen in here, and its temperature increases away from what? From the sun. The temperature increases as with distance from the sun. And then number three, I already mentioned to you that we have got what is called photosphere is the visible from is visible from the earth, plasma clouds emanating from the sun, and supports and sunspots can be observed in the photosphere. As you can see, we are saying it actually the part of the sun that gives us the light, which you can see from this diagram that we are sharing on the board here. And then we have got the inner core. The inner core is the thermonuclear fusion happens in the core, in which a considerable amount of energy is released in the form of form of photons and the gamma rays. So now, which is happening at the core, which you are seeing is the whitish patch there that you can see as you look on number 4 on the board there. So we have got the radiative zone, which is radiative is energy. We are saying energy is spread from the what from the core through through radiation, in which colliding uh, with electrons gradually lose their energy and change their properties. So radiative zone, it actually allows the spread of energy, the spread of heat energy from the sun, which is actually caused because or the transfer of heat energy through the space. And then we have got lastly the convection zone, which is number 6, the convection zone, that is number 6 that you can see there. An energy transfer takes place through the convection, turbulence, steaming, and mixing the material. So there is fluid that is in the convection zone, which energy transfers through the fluid particles by the bombardment and movement of the fluid molecules that are receiving and getting heat energy and passing it to each other in a convection kind like fashion. So that is the structure of the sun that you can see there. And then the sun produces heat and light energy and is mainly of hydrogen and helium gas, where atoms of hydrogen are continuously reacting with each other to form helium. So the atoms of hydrogen, they continuously react to each other and they form what? They form helium gas, which is called the nuclear reaction. Uh, when the hydrogen atoms, they continuously react with each other. In that regard, we have got the production or the formation of helium gas, which actually we call nuclear reaction, producing vast amounts of energy in the form of heat and light energy, which we are saying these are the forms of energy which the sun produces. So nuclear reaction is a type of reaction in which the nucleus of the atom changes its characteristics and becomes something else. The nucleus of an atom changes their properties and becomes something different. So the heat and light energy produced travel in all directions in the space, which we said it travels through what? Through radiation. The heat, the light and heat energy that is produced travels in all directions, and then we said it travels through radiation, where some it reaches the earth, making life possible on planet. Life on planet, it happens because of the light and heat energy that radiates from the sun. We are going to go deep into the characteristics of which we are going to look at them just as we continue right now. And then objects around the sun are our solar system. It contains a variety of objects that orbit, that rotates. We said orbit, we said move around. They move around, or we say they rotate around the sun, including 8 planets. The 8 planets, I'm sure that we know the 8 planets. We need to understand that we have got Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Of course, and their moons that they have. There are some of them that have got moons and others they do not have. So these are what you call the objects that are surrounding around the sun or that are around the sun. So rock storage we have got the rocky asteroids, the rocky asteroids, which are found mostly in the asteroid belt between Mars and Jupiter. So They are found basically in the asteroid belt between Mars and Jupiter, and then the outer dwarf planets such as Pluto are located in the Kuiper belt, and then icy dusty objects are in the Kuiper belt and Otto cloud at the solar system's edge. I have got diagrams that I'm going to show you in terms of the positioning of this Kuiper belt and the Otto cloud, also with relation to the solar system, which we are finding that you should see that the sun and the objects in the region of space around it are known as the solar system. We say the solar system referring to the sun and objects in the region of space around it. So the sun is at the center of the system. The sun is at the center of the system. So we have got our 8 planets, which we actually have identified there. So with regards to the 8 planets, I always want you to understand and relate that, I mean, to make sure that you don't forget uh, concepts and issues that have to do with the planets, to say that you need to know the name of the planet and the characteristic of each planet. In terms of the planet, you have to know, you need to know the planet and its characteristic and its characteristics. You can be able to, if you do that. For example, I want you to know that for Mercury, for example, we say Mercury 1, it is the surface. I mean, the surface looks like the moon with the plains and craters. When we look on Mercury, we are saying it is actually, yes, the surface that looks like the moon, and with the plains and also what craters. We have got the Venus, which has the surface, has many volcanoes, and it shines brightly. The Venus, it has got the surface which actually has many volcanoes. Surface, yes, it has many volcanoes. Of what? Of Venus. Surface has many volcanoes. And then one other thing again is that we need to understand that again, that it shines brightly. Venus shines brightly. Venus, it shines. It shines brightly. Venus, it shines brightly. And then we can also want to understand that we have got the Earth, which is called the blue planet, with oceans covering plus or minus 70% of the surface. I'm sure you know that the Earth, much of the length of, or much of the space of on Earth is actually covered by water, which is plus or minus 70% of what, actually plus 70% of the surface is water. And then Mars is actually this planet, which is also called the red planet. Mars, which is also called the red planet, uh, as you look on the what, on the types of planet. And then when you talk about Jupiter, this planet is almost twice as heavy as the what, as the total mass of all the other planets in our solar system. You need to understand that it is actually is twice as heavy as the total mass of what, of all the other planets in our solar system. It is almost as bright as Venus, almost as bright as Venus. And then we have got the Saturn. This planet actually is very beautiful. It's got very beautiful rings that surrounds it. Venus, so we are saying Saturn, it is actually, it's got very beautiful rings that surround it. When you look at Saturn. And then Uranus, it is actually one that looks like other gas planets, but green, and also rotates on its side. Lastly, I can maybe talk about Neptune, which I want you to know that it looks like other gas planets, but looks bluish. It actually looks bluish. So I was saying that some of the times you shall hear that we have got the terrestrial planets, which we are going to discuss just right now as we go, to say that the terrestrial planets is, for example, we have got the Mercury, the Venus, Earth, and what? And Mars are called terrestrial planets, which are closest to the sun, and actually hence are also very smaller, and have a metal core, rock mantle, thin outer crust, and a thin atmosphere. So now, actually, the Earth's atmosphere is what is unique in the solar system, because it contains abundance of what? Of oxygen. The Earth actually contains abundance of oxygen in the atmosphere, which is actually necessary to sustain life on Earth. Basically, these are some of the things that we need to look at as we look at what? At the planets. And then planet is surrounded by is surrounded by body traveling around a star in a clear circular path. I mean, it is a celestial body that orbits. We say that moves. A star has enough mass of its gravity to create a nearly round shape, and has cleared its orbit of other objects. We are just defining some of the features of a planet. Just defining some of the features of the planet. So the planet Earth is only planet known to support life class. The planet Earth is the only planet that is known to support life thanks to its unique conditions. There are some unique conditions that are known of what? Of the planet Earth. One, we say what? It has got the temperature. The Earth's distance from the sun provides an ideal temperature range. The ideal temperature range for what? For survival of both plants and what? And animals. It actually provides the ideal conditions. Temperature is actually ideal for survival of plants and animals. The planet Earth also has water. Water exists in liquid. It exists in the gas state, and also solid. And then within the Earth's temperature range, I'm sure that you know we have got areas that are very cold, which also tend to have water in their solid state, which we talk about the Antarctic regions, or regions that are close to the sea. I mean, to we call like polar regions, where temperatures are constantly very low. So we end up having islands. So in these islands, they result in water in the solid state. And then sunlight, also we say that is another condition that we have in this on Earth planet, provides the energy needed for the food chain. Our food chain, when we look in ecosystem, I'm sure that we remember that our ecosystem, our Earth, is a mass of interdependentness of what? Of various systems, which actually are transferring energy from one to another because of what? Because of the sunlight. And then oxygen also, which we say that oxygen produced by early life forms are produced by early life forms and algae, allowing sophisticated life forms to evolve. Uh, Oxygen supports the living, like animals. In terms of oxygen, we are saying to support animals. Oxygen is needed to support what? To support animals. Animals are supported because of the oxygen that is also available on Earth. So, characteristics of objects in space to be called a planet. We are looking at criteria for planethood. What criteria qualifies objects in space to be called a planet? If objects are in space, what qualifies them to be called a planet? So one uh characteristic number one, it has to orbit a star. The celestial body must be in orbit around a star. It must travel around the sun in a regular circular path or orbit. Remember, we said the sun is a big star. So therefore, when we identify objects in this objects in space to be called a planet, they must be able to travel around the sun in a regular circular pathway, which defines that orbit that we've been talking about. And then it must be nearly round in shape. It must be nearly round in shape. It must possess enough mass uh, for itself gravity. It must possess enough mass for itself gravity to overcome rigid body forces, resulting in a hydrostatic equilibrium or a nearly round shape. That shape is because of the what? Because of the self-gravity that it must possess in order to overcome the rigid body masses, rigid body forces. So it must be, uh, therefore, it can also just to be nearly round in shape, be almost spherical in shape. It must be almost spherical in shape, and then cleared its orbit. It must clear its orbit. The object must clear the neighborhood around its orbit. When an object in the space can be defined as a planet, it must have the capacity to clear the neighborhood around its orbit, meaning it is the dominant gravitational body in its orbital region, which at the same time in its orbital region, which at the same time be able to keep its orbital path clear of other objects. No objects must be there to distract uh, the pathway. So clear its orbit is a characteristic that an object must have to be defined as a what? As a planet. So it must it is it it must be dominant. It must have dominant gravitational body in its orbital region, hence be able to keep its orbital path, its pathway clear, or its rotational path clear of other objects. So scientists divide the 8 planets into 2 groups. Planets are divided into 2 groups. We have got the inner rocky planets, the inner rocky planets the inner rocky planets, which is Mercury, Venus, Earth, and Mars, which are all made up of the rocky, and they are terrestrial planets, meaning to say that they relate to the land. They relate to the land. So these planets are called inner rocky planets. Mercury, Venus, Earth, and Mars. And then we have got category number 2, which is the outer gas giants, which has got Jupiter, Saturn. It has got Jupiter. We have got Saturn. We have got Uranus. We have got Neptune, which are all made up mostly of gases and liquid. So you can see the difference in the categories of the inner rocky planets and the outer gas giants. The inner outer gas giants, we have got we have got these 4, which is Jupiter, Saturn, Uranus, and Neptune, which are made mostly of gases and liquid. They are all larger than terrestrial planets. They are larger than terrestrial planets and are of groups and are a group of planets further from the sun. They are a distance from the sun. So dwarf planets are celestial bodies that orbit the sun. Dwarf planets, they also are celestial bodies that also rotate around the sun, are massive enough to be rounded by their own gravity. They are massive enough to be rounded by their own what? By their own gravity, but have not cleared their own orbital pathway or other objects. So what happens is that their pathway is blocked, hence we cannot classify them as what? As planets. So the International Astronomical Union, which we call IAU, currently recognizes 5 dwarf planets. There are 5 dwarf planets that are recognized. We have got the Ceres, we have got Pluto, we have got the We have got a Make, and then the Aries. The key difference between a planet and dwarf planet, which I want you to take note of. We can say NB, the key difference between planet and dwarf planet is this this ability, I mean the inability to clear its neighborhood around its orbit. Dwarf planet cannot be able to clear their pathway, their orbit. They are not able to clear around their orbit. So we call them that dwarf. So Pluto was reclassified as dwarf planet because if you look at this, we are saying Pluto was reclassified as a dwarf planet because uh, it meets the first two criteria, of course, but it has not cleared its orbit. It has not managed to clear its orbit, and other comparable objects share its orbital pathway. Other comparable orbits share its orbital pathway, meaning to say that the pathway is not cleared, and Pluto orbit overlaps with that of what? Of Neptune. So it overlaps, therefore it means it also meaning to say that it's what is obstructed. And then finally, the characteristics of dwarf planets are the characteristics of dwarf planets. We have got the orbit the sun, they orbit the sun, and then they are not moons orbiting around, I mean, another planet, but instead directly orbit the sun. They actually rotate around the sun. They are nearly round. They are larger enough for their gravity to pull them into a nearly spherical shape. They are nearly round, and then uncleared orbit. That is one other key feature that we identified up there, that they've got their pathway uncleared. So unlike the planets, dwarf planets have not cleared their orbital path of other debris, such as the asteroids and other small bodies. We say that some small rocks are elements or small rock particles that are found in the space. So the debris are found in there, which are asteroids or other what small bodies. And then not a moon, they are not a neutral satellite, which we are saying that the moon. So I want to appreciate you, Classy, for your time and following. Let's just finish the remaining few areas of term 4 work, and then we'll be able to actually write our exams and qualify to go to grade 9 with no work left behind. So thank you very much for tuning on and also connecting to Metric Hub. Don't forget to subscribe, like, and also share. Let's get engaged. Let's interact together here. This is our only channel of virtual class. I've been always saying that virtual class is the only way of breaking our limitations, education and information being brought at our doorsteps. Let's do it now. Don't forget to subscribe, share to others, keep connected. We can do this together. Future leaders through one click at Metric Hub is there for you. Keep connected. Let's do it together right now. Thank you.